Hi, I'm Keith Young, and today I'm going to show you how to install the TMC2208 driver. In this video, I will be installing the drivers into a TiVo Black Widow printer, but most of the information in this video will be applicable to most printers running Marlin firmware and compatible boards like the MKS Gen V1.3 or 1.4. The TMC2208 is the latest silent stepper stick driver for Trinamic. At a max rated continuous current of 1.4 amps and a peak of 2 amps, the TMC2208 makes the perfect upgrade driver for large printers like the TiVo Black Widow. The TMC2208 is also perfect for smaller printers. The two main reasons to upgrade to a TMC2208 driver is to remove the salmon skin artifact from the surface of your prints and to reduce the noise created by the stepper motors during printing. The TMC2208's default configuration is set to the new Stealth Chop 2 mode. If you are running a small printer, then you may want to try this mode. If you do want to try Stealth Chop 2, you may skip to the end of this video and just plug the driver in, as it will work without further modification, except for the tweaking of firmware and jumpers, which I will cover later in this video. However, if you find that the printer does not work properly using Stealth Chop 2, then you will need to configure your 228 for spread cycle mode. For printers the size of the Black Widow or larger, I recommend giving Stealth Chop 2 a miss and go straight for spread cycle mode. Configuring for spread cycle is more of an insurance policy, as you don't want to get halfway through a 20-hour print and find out that the driver's overheated and started skipping steps. Although the stepper motors will sound a little louder in spread cycle mode, it is still significantly quieter compared to drivers like the DRV8825 or the A4988. The spread cycle mode is suitable for most printer applications. To configure your drivers for spread cycle mode, continue watching. According to the Trinamic documentation, there are 3 ways to get the driver into spread cycle mode. The first way is standalone driver. Solder and configure jumpers in a method similar to the TMC2100. But at the time of making this video, there is not a confirmed working method I can show you to do this. Trinamic call this legacy mode. Legacy mode means that the driver will work just like the old drivers. The second way is the standalone driver with OTP pre-configured mode using a ftdi UART encoder board connected directly to the computer. Once configured, the drivers will be in spread cycle mode instead of Stealth Chop 2, and that's exactly what we want. Similar to legacy mode, but without as much soldering as the previous method. Once configured, the driver can be plugged in and is ready to use. And the third way is driver with full diagnostic and control. Also connected through the same UART connection as above, but this time directly connected to the printer's control board. In this mode, the driver's settings are stored in the printer's EEPROM and uploaded to the driver at startup. No settings are actually stored in the driver. This requires one of the pins to be soldered pointing up and extra wires connected to the control board. In this configuration, all driver settings can be configured through the Marlin firmware. This video will show you how to configure your TMC2208 in the simplest way, which is the standalone driver with OTP pre-configuration. Later I hope to revisit the 2208 and produce a video detailing the more complex driver with full diagnostics control mode. Even though the connection of the TMC2208 to the board is quite easy, at this stage there is still reported bugs in the Marlin code that need to be sorted out to make full use of this capability. Before we go any further, with this tutorial you will need the following items. In the way of hardware, you will need your TMC2208 drivers, a Windows computer running Windows XP to Windows 10. You'll also need an ftdi breakout board, a USB cable to connect the ftdi breakout board to your computer, a USB cable to connect your 3D printer to your computer, a selection of jumper cables that connect the ftdi breakout board with the driver, a 1K half watt resistor, miscellaneous tools including a wire cutter, solder and soldering iron, and of course a 3D printer running Marlin firmware. In the way of software, you will need a copy of Marlin firmware configured for your printer, Arduino software to reinstall the firmware, the Script Communicator software, and the TMC2208 SCEZ script file. I will show you where to download the TMC specific software as we go along. As detailed in the hardware list, you will need to get an ftdi or UART connector. To confirm that you have the right type, look to see that it is fitted with the FT232RL chip. When shopping for one of these boards, search for ftdi, UART or FT232RL, or any combination of these terms. Some of these boards will come with a set of connector wires. If you don't have any connector wires, then get a board with the wires. At the other end of the board connects a USB cable. Most people already have one of these, as they are the same type of cable that connects cameras and other electronic devices to computers. Check to see that you have a compatible USB cable that will fit the ftdi board. Most have a mini USB plug. Before connecting up the driver and the ftdi board, you will need to connect a jumper on each of these drivers. On the connection diagram, these two connections are marked in orange. On the ftdi board, there are 3 pins that poke out from the top. Make sure there is a jumper connecting the center pin with the pin marked 5 volts. If your ftdi board does not come with a jumper, borrow one from the printer's board. On the TMC2208 driver, you will need to put a drop of solder across 2 pads. These pads are between the PDN pin and the 228 chip. This connection activates the UART connection used by both the ftdi board and later on in the full diagnostics and control mode. The next step is to make the connection cables. A Y lead is required so that the VCC output on the ftdi board connects to both the VIO and the VM pins on the driver. Another Y lead needs to be made to connect the TX and RX pins on the ftdi board to the PDN pin on the driver. The TX part of the lead must have a 1K resistor spliced in. The ground cable is a direct connection and can be used as is, as it does not need any modification. So that's the ground, that's the VIO. Okay, and this one's the VN. And this one here is the PND. That's the wrong end. It's just one cable, and we'll connect here like that. Alright, so we've got the white cable to the PDN pin, the black cable going to ground, the red cable going to VIO, and the white cable going to the VM. We follow the VM, the VIO, they've been joined together on this yellow cable, and the ground is the black one. So ground black, have a look here, we'll connect that there. This is our ground pin, this is our 5 volt out pin on the UART or FTDI breakout board. This one here, we'll connect that up there. This pin here going to the circuit board connected to the PDN pin joins up here. The side with the resistor goes to the TX side, the one that goes straight through goes to the RX. At this stage you will need to jump onto your Windows-based computer and download and install some files. At this time the video was made, Trinamic do not have any Mac-based software for this to work. Download the Script Communication software and the TMC2208 SCEZ file from this site. I'll also upload these files to a zip folder and provide a link, just in case the TMC2208 GitHub page changes. Install the Script Communication software. If an error occurs, right-click on the installer and click on Run as Administrator. If the program starts after installation, just shut it down. Instead, double-click on the TMC2208 SCEZ file. The script communicator will start running the TMC2208 script. You will now want to connect your ftdi board to the computer. Make sure all the wires between the ftdi board and the driver are securely connected before connecting the USB cable to the computer. Make sure the computer is on and has finished booting up before making the USB connection. Carefully connect the ftdi via the USB cable. When connecting the ftdi board for the first time, Windows will automatically detect it and start to install the ftdi drivers automatically. Wait for the installation to complete before unplugging it or trying to use it for the first time. This could take up to 5 minutes or more depending on your computer. Open up the device managers via your Start button. Look for any new USB device on your list like FT232R, USB UART or similar. Double click on this device and open up the device properties. Click on the Hardware tab. The name of the USB serial port will be named here. Take note of the COM port number. In my case, it's COM port 7. Go back to the Script Configurator window and select your COM port number and press the Connect button. On the opening screen, check the run current. The factory default should be 1.77 amps. No actual adjustment made on this first page will have any effect, as the settings will be lost when the driver is disconnected from its power source. Instead, click on the OTP Programmer tab. Here is where you'll permanently enable the spread cycle mode. In the first window, OTP byte, set this to 2. In the second window, OTP bit, set this window to 7. Confirm that the name description below now reads OTP 2.7. Click on the write 1 bit to OTP memory. Click yes, and OK. Changing this setting has just set the T-off setting to 0. Now you need to set the T-off equals 2. To do this, go back to the first OTP bytes, set this to 1. In the second window, OTP bit, set this also to 1. Confirm that the name description below reads OTP 1.1. Click on write 1 bit to OTP memory, click yes, and OK. You can now check that the setting is now permanent by unplugging the USB cable and plugging it back in. You will notice the N_spread cycle box is now checked and the setting on the T-off setting is now 2. Your driver is now ready to install. Repeat this process with each driver. If you are wanting to try the Stealth Chop 2 mode, this is where you should rejoin the tutorial. At this time you can attach the supplied heatsink to the back of the driver board. Try to get the heatsink directly opposite the TMC chip and make sure it does not touch any of the pins. Let's install the drivers onto the printer's main board. In this example, I will be using an MKS Gen V1.3 board. Before the drivers are put into place, the jumpers on the MKS board need to be set so that the driver is set to 16 microsteps. This is done by installing both the MS1 and MS2 jumpers. The third jumper, the MS3, has no effect for the TMC2208, so that jumper can be left in or removed. If you do not know which jumper is which on your particular board, then just leave them all in. When putting the drivers into position, make sure the drivers are orientated in the right direction. The end of the driver with the potentiometer and the 3 holes goes towards the end with the power connectors. Now a quick note on driver cooling. After running these drivers for quite a few hours at relatively high jerk and acceleration settings, they do become quite hot. They run 50% hotter than the old DRV8825 drivers at the same settings. To counter this heating, I have designed and installed a dedicated cooling duct into my control box to cool the drivers. I highly recommend cooling your drivers, especially if you intend to make your printer go faster at a later date. I will provide a link to the cooling duct I used for the MKS board in the comments below. Once you have installed your drivers, you will more than likely need to update the settings in your Marlin firmware. If you are upgrading from the TMC2100 driver, then no settings need to be changed. If you are upgrading from the DRV8825 driver, then you will need to reverse the direction of the stepper and also halve the number of steps for each driver. For other printers with other drivers, you may need to refer to your printer's documentation as to the printer's steps and direction. If you need to reverse your motors and halve your steps, continue watching. Now my Black Widow firmware is set to 32 microsteps to suit the factory default of the DRV8825 drivers. The TMC2208 requires the firmware to be set to 16 microsteps. If you have already configured and calibrated your drivers for 16 microsteps, then you will not have to touch this setting. The other settings to adjust in the Marlin is to reverse the direction of the stepper motors for each TMC2208 you've installed. Now if you've not installed the Marlin firmware before, then it might be best to refer to your printer's documentation or find a video on how to install Marlin, as I will only show what needs to be changed to make the TMC2208s work and not cover other issues with installing the Marlin firmware. Make sure you have installed the Arduino software on your computer. Go to the folder that contains the marlin.ino file. Double click on it. The Marlin configuration firmware will open up. For the Black Widow, click on one of the following applicable tabs. For other printers, refer to your printer's documentation as to which tab you need to select. Now press Ctrl F. This will bring up the search dialog. Type reverse. Then click Find. You are looking for the line that says invert stepper direction, change or reverse the motor connector if an axis goes the wrong way. Under this you will find define data. Change each of the false to true and vice versa for each driver you have installed. A couple of lines below these you will find the extruder stepper define data. Define invert E0 dir false. Also change this if you have installed a 2208 on the extruder. If you have changed all the drivers, the direction should be true, false, false, true. Now to adjust the steps. With the same configuration tab open, press Ctrl F, and this time search for steps and find the line define default axis steps per unit. Then you'll see in brackets 4 numbers. You'll need to halve the value of each number found in the brackets. 160, 160, 3200, 935 will become 80, 80, 1600, 468. Note, the last number in this sequence is your extruder E steps and should have been calibrated when you first set up your printer. Retrieve your current extruder steps from the printer. select the main menu, then the control, then motion, scroll down to the bottom, and you'll find your E-steps. Mine used to be 866, and as you can see I've already set this to 433. Press Ctrl S to save the changes to the Marlin code. Make sure your printer's on and connect the USB cable between your printer and computer, and upload the adjusted Marlin code to your printer's control board. Perform an auto hone and quickly get ready to press the off button if it goes the wrong way. The printer should hone normally. Print a test cube to confirm that all operations are normal. Measure the cube and recalibrate as required. Thanks for watching my tutorial today, and I hope to present some more tutorial how-tos shortly.